Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard, and today we are looking at this question too. It's an extract from my book, Physical Sciences Silver Bullet, and yes, let us look at it. The statement reads that calcium was added to 180 cubic centimeter of that concentration of each cell. The rate of reaction is measured using setup below, measuring the loss in mass of the flask and its content at regular interval. And after completion of the reaction, it was found that 1.2 grams of calcium powder is present. And the first part says, write equation for the reaction taking place. We know this is not a typical question you are used to find in the rate, but let us try our magic on it. So what are we having here? We are having the reactants here. The reactant is calcium. It's a solid reacting with HCl. If you perform this inorganic reaction, what do we have? Calcium attacks the chloride. Don't forget that the valency of calcium is 2, so we have that one plus hydrogen. Remember, it exists as a diatomic molecule. So that's the reaction we are having. What are we missing? Balancing the equation. Now it is balanced. Okay, next question. Okay, yeah, then comes the next question. It says, name the gas given out. From the reaction, we can tell the gas which is being given out. The gas is this one. So it is hydrogen. Okay. Then comes this question. It says, identify the reactant which is the limiting reagent. Okay. How do you go about that? Now, you have to know what the limiting reagent is. A limiting reagent is the reaction which is going to make the reaction to stop. It is the one which is served in less amount, such that during the reaction, once it is finished, the reaction stops. So it determines when the reaction stops. So how do you tell that is the limiting reagent? We can look at the statement. There's something we have to look to know here. Here they said something. They said after completion of the reaction, it was found that 1.2 grams of calcium powder is present. So what does that mean? That calcium powder is oversupplied, and we have two reactants only. One is calcium, the other is hydrochloric acid. So the limiting reagent is the one which is supplied in less amount, so that when it is finished, the reaction stops, and that is going to be hydrochloric acid, HCl. Okay. Yes, we come to this question. It says, sketch the graph of mass of calcium in the flask versus time for the reaction and label it X. So when you look at this case, you have to ask yourself, what happens to calcium as time proceeds? Actually, the best question to ask, does calcium increase or it decreases as time proceeds? You have to know that calcium is a reactant and the reaction is taking place. So what happens to its amount as time passes? As it reacts, its amount in the flask decreases. So in this case, we are going to have our graph as that. That's going to be the graph. It decreases as time passes. Thank you. And they said we label this graph what? X. Thank you. Yeah, then comes this question. It says 2.4 that on the same set of axes above, sketch the graph which takes place at higher concentration. Okay. Yes, when you increase concentration, what actually happens? What happens is that the reaction rate will increase. The rate at which calcium is being consumed will increase. And how do you show the extent of the rate on this graph? You have to know that higher rate takes less time to reach compression. So, which means that our graph Y will be like that. It will, remember, when the graph flattens out, it means that it has reached compression. So this one reaches compression before the other one. So that's the graph we are having. Okay, no. Let's look at the next question. Okay, then comes this question, 2.5. It says, using collision theory, explain why graph Y differ from graph X. Okay. So why graph Y differs from graph X using collision theory? So when you look at the two graphs, the first aspect you consider is what is causing the deviation between the two graphs. The factor is concentration. It is concentration causing the changes we are seeing. And when it comes to collision theory, what does concentration do to increase the rate of reaction? Actually, it increases number of particles per unit volume. Actually, concentration is number of entities per unit volume. So this graph Y has higher number of particles per unit volume compared to graph X. What does that mean? When the number of particles are more per unit volume, the frequency of effective collision will increase, and so increases the rate of reaction. Let us put that one down. So that is that. Increase in concentration increases the number of particles per unit volume. So the keyword here is that number of particles per unit volume. This increases the frequency of effective collision, which increases the rate of reaction. So generally that's what you're supposed to do on that part. Let us go to the next question. Okay. Yeah, then comes this question. it 2.6. It says, on the same set of axes, sketch graph Z representing reaction when granules are used instead of calcium powder. Okay, you have to remember that the graph we have, which is X, we had hydrochloric acid with powder. Now you are taking out the powder and replacing it with calcium granules. So what do granules do? Okay, you have to know that one of the factors which affect the rate of reaction is surface area. And powder have a bigger surface area compared to the granules. So the reaction with powder is faster compared to the reaction with the granules. So what are we seeing here? That our reaction rate is going to decrease. And how do you show decrease in the rate on this graph? We show it by realizing that the time taken to reach compression will be higher. So this is what our granules will be. The time taken to reach compression is higher. And we said it's Z. So that's what we have. Now, we are going to cut this video here and call this one part 1 of question 2. Please stay with us as we proceed to the next video, which involves calculation of rates of reaction, which is going to be part 2 of question 2. See you then, and don't forget to subscribe, and also please don't forget to like our videos. Don't be selfish. Selfish people don't go very far. So when the video has made an impact on you, please like it and also recommend it to a friend. See you then. Bye bye.